Hey guys, let's go ahead and review for the Chapter 5 Calculus exam. Now, when you take the exam, you will have questions about exponential growth, exponential decay, values that are compounded continuously in half-life. Notice that these formulas, they change them a little bit here and there, like we have a lambda instead of a k. We have an R for PERT, meaning your interest rate. But really, for all of these, you do have the same formula. When you want to do elasticity of demand, remember elasticity is based off of your price. So the formula is negative P, which means the price, times the derivative over the original. If you want to find relative rate of change, that is the derivative over the original. You do not have a formula sheet for you on the test. You do have to know them. But again, these are basically the exact same thing. You just need to know relative rate of change, derivative over original. To do elasticity, you take that relative rate of change and put a negative P on the top. Let's do some sample problems. How long would it take for an investment of $3,200 to triple if the interest is 16% compounded continuously? Compounded continuously is the PERT formula. We are asking how long something would take. So we're solving for T. The principal, how much money are you investing? That is 3,200. E to the R. R is your interest rate as a decimal. 0.16. We want to know how long, how many years, until this triples. Well, triple means that this amount would be multiplied by 3, giving you 9,600. That would be your setup for the first question. Then to solve for T, step 1, divide the 3,200 over, and you would have 9,600 divided by 3,200, that is 3. To cancel E, you need to take the natural log of each side. If I take the natural log of 3, I get approximately 1.099. Now to solve for T, I go ahead and divide each side by 0.16. So 1.099 divided by 0.16, T is approximately 6.87 years. So if you invest $3,200, if it's compounded continuously at a 16% interest rate in just a little under 7 years, your original investment would triple. Okay, here is a half-life question. Radium-226 has a half-life of 1,600 years. Half-life is always used to help you find lambda. So before I even go any further, I'm going to go ahead and calculate our decay constant. If I have 1 gram of radium-226, e to the negative lambda, in a time of 1,600 years, my 1 gram would decay down to half of the amount, so I'd have half left. Half-life, 1,600 years, I put that in for time. If I divide by 1, and I take negative lambda times 1,600, it's negative 1,600 lambda equals 1/2 divided by 1 is 1/2. You could write it as a fraction or as a decimal. Next, take the natural log of each side. Negative 1,600 times lambda is approximately, the natural log of 0.5 is negative 0.693. To solve for lambda, which is your decay constant, I just have to go ahead and divide by negative 1,600. So negative 0.693 divided by negative 1,600, it's 0.00043. And again, I rounded. Okay, so that is our decay constant. Now I can go ahead and go back to the problem and see what they want us to find. After a time of 5,000 years, a given sample of radium-226 contains 8.2. What that means is a given sample, we do not know how much we're starting with. But after 5,000 years, what we have left is 8.2 grams. How large was the original sample? So I do not know the initial amount. E to the negative lambda, the reason it's negative is because this is a decay problem, a time of 5,000 years. In 5,000 years, we started with some amount and we ended with 8.2. The beautiful thing about this, you guys, you can put that in the calculator, and that is a number. So P sub 0, how much of the element did you start with? We don't know. But if I go ahead and I say E to the negative 0.00043 times 5,000 years, this is 0.116. So 0.116, that's approximately 8.2. Again, I changed this to approximate because I rounded this. To find the initial amount, you just have to go ahead and divide. So if I take 8.2 divided by 0.116, my initial amount was approximately 70.6897, so even approximately 70.7 grams. So you started with about 70.7. 5,000 years later, you still had some left, but it was down to 8.2 grams. All right, let's look at another sample question. $1,750 is invested at 4% interest compounded continuously. Compounded continuously is the PERT formula. Write the equation that you could use to calculate the balance of the account. So I'm just filling in what I know. I am starting with a principal value of $1,750. E to the interest rate. Your interest rate is 4%, so that's 0.04 times T. And remember, when you're calculating compounded continuously problems, T is always in years. So here would be my formula. What would the balance be after 9 years? That means T equals 9. 1750 e to the 0.04 times 9. Fill that in. 1750 e to the power of 0.04 times 9. You would now have an amount of $2,508.33. Okay, so there's another compounded continuous, making sure you're comfortable with that formula PERT. Okay, next one. If f of x equals negative 0.02x squared plus 60x, determine the relative rate of change. Again, you want to make sure that you convert that final answer to a percentage if x is 22. Relative rate of change, that is derivative over original. Relative rate of change is the derivative over the original. If I find the derivative of this, 2 times negative 0.02 is negative 0.04. Reduce the variable by 1, so it would just be a single x. Plus, the derivative of 60x is 60. So that is the derivative. The derivative goes on top. The original goes on the bottom. Here is the formula. You want to know what the relative rate of change is, making sure that you turn it into a percentage. If I replace all of the x's with 22. So on the top, negative 0.04 times 22 plus 60. My top, I have 59.12. The bottom, negative 0.02 times 22 squared plus 60 times 22, 1310.32. Go ahead and divide those. 59.12 divided by 1310.32, approximately, because I'm rounding, approximately 0.045. Turn it into a percentage. So your relative rate of change is approximately 4.5%. The only thing you have to remember there, if you see relative rate of change, derivative over original. Okay, here's another half-life problem. If I'm looking at potassium 42, it has a half-life of 12 hours. Again, the half-life helps you to figure out lambda. So if I start with 1 gram of potassium, e to the negative lambda, the time, the half-life is 12 hours. That means if I start with 1 gram in a time of 12 hours, I'm down to 1/2. If I divide both sides by 1 and I multiply the exponents together, I would have e to the negative 12 lambda equals 0.5. To solve for lambda, natural log of each side, so negative 12 times lambda is approximately Natural log of 0.5 is negative 0.693. Go ahead and divide. Negative 0.693 divided by negative 12 is 0.05775. That is your decay constant. Now we keep going. How long? So we are looking for a time. We're solving for T. How long would it take for an initial amount of potassium to decay to 1/8 of its original size? Well, they did not tell us the original amount, so we get to pick whatever number we want. I'm going to use 1. So if I'm starting with 1, e to the negative lambda, 0.05775. The question is how long? So we're solving for T until we have 1/8 of the original left. Well, if I'm starting with 1, I want to know when it would be down to 1/8. Go ahead and divide both sides by 1 to get rid of that number in the front. If I take 1 divided by 8, I can write it as a decimal if you prefer. It's 0.125. Take the natural log of each side, so negative 0.05775t. It is approximately, the natural log of 0.125 is negative 2.079, so I'm going to say approximately 2.08. To find the time, go ahead and divide. Negative 2.08 divided by negative 0.05775. I got approximately 36. It's time. Our time was in hours. Okay, so there's another half-life problem. Let's look at another question. Assume that the demand function for a given product is Q equals 925 minus P minus 0.06 P squared. Remember your demand equation. Q represents the quantity. Another way that you can do this instead of Q equals is F of P. So F of P is 925 minus P minus 0.06 P squared. If you are finding the elasticity, the formula is negative P times the derivative over the original. In order to find the elasticity of something, you calculate this value. If the value is larger than 1, it is elastic. If it is less than 1, it is inelastic. So in order to do this, I have my original function. I need to find the derivative. Well, the derivative of 925 is a constant, so this is 0. The derivative of negative P is negative 1. 2 times negative 0.06 is negative 0.12. P squared becomes a P. So to set this up, it's negative P times the derivative on the top. Negative 1 minus 0.12 P. Before I go any further, I'm just going to go ahead and distribute that negative P. Negative times a negative is a positive. P times 1 is P. Negative times a negative is a positive. P times 0.12 P is 0.12 P squared. That is the top. Over the original. 925 minus P minus 0.06 P squared. Here is the formula. Now to find out if it's elastic or inelastic, you have to fill in the price. So I'm going to go ahead and change P into 40. So if I go to the top, it's 40 plus 0.12 times 40 squared. 232. On the bottom, 925 minus 40 minus 0.06 times 40 squared. 789. So to calculate my value, 232 divided by 789, I have 0.29. If I have 0.29, 0.29 is less than 1. If it's less than 1, you have a problem that is inelastic. Remember, inelastic means that they're going to do the same thing. If you raise the price, the revenue raises or goes up as well. If you drop the price, your revenue will also drop. Inelastic, what you do to the price, the same thing will happen to the revenue. If it's elastic, they pull opposite of one another. So if you increase your price, your revenue decreases. If you lower your price, your revenue increases. So inelastic, they do the same. Elastic, they're going to do the opposite. Okay, here's another question. 250 bacteria are placed in a culture. Let P of T, this is the function, let the function be the number of bacteria present in the culture after T hours. They're also telling us that our differential equation is 0.20 pt. Remember, in your differential equation, whatever your K value is, your constant, that's what goes in front of the population. So here are some sample questions. What is P of 0? Meaning at the beginning, how much bacteria are you starting with? We are starting with 250 bacteria. Find P of T. This means find a formula. Our formula is 250 e to the K. K is your growth constant. It is 0.2 times T. So this is the formula you could use to figure out how much bacteria you have based off of time in hours. How many bacteria would be present after 24 hours? That means T is really a 24. 250e to the 0.2 times 24. Now I can just go ahead and plug that in. 250e to the 0.2 times 24. It is bacteria, so I'm going to round it to the nearest whole unit. We would have 30,378 bacteria. Pretty gross. So we started with 250. In a time of 24 hours, it grew to 30,378. Last, what is the growth constant? That's remembering that your derivative, your growth constant gets multiplied to the current population. So our growth constant in this problem would be 0.20. Moving on, last page, guys. The size of a certain insect population is given by this formula. Okay, so this is how you can figure out the population of insects. T is measured in days. How many insects were present initially? So what is your beginning amount? That's the number that goes out front. So at the beginning, there were 300 insects. Give a differential equation for P of T. That means how could you figure out the rate that the insect population is growing? So the derivative, remember your derivative is the growth constant. So in this case, it's 0.01. You multiply that by the current population. So this would be your derivative. At what rate? When you see the word rate, it means you're finding the derivative. So we're going to actually use the formula that we just created in step B. At what rate will the population be growing when the population, P of T, equals 5,500? So your rate, which is the derivative, is 0.01 times 5,500. So 0.01 times 5,500 is 55. It's positive, so you have an increase of 55 insects per unit of time. T is measured in days, so at that rate, when you have 5,500 bugs, what's going on is every day you are increasing that amount by 55. At what time, so we're looking for T, at what time will the population reach 2,800? So that is our original function because it's based off of the population, not the rate. Our original function is 300e to the 0.01t. You want to know what time our population will reach 2,800. So I need to solve for t. If I divide both sides by 300, I would have e to the 0.01t is approximately 9.333. To cancel e, natural log of each side. So 0.01t is approximately the natural log of 9.333 is 2.23. To find t, I have to go ahead and divide by 0.01. 2.23 divided by 0.01 is approximately 223 days. So if you started out with 300 insects, in 2,800 days, if you did nothing to stop the growth and you didn't have any bugs die, at the end of 223 days, you would have 2,800 insects. Kind of crazy. Last part of this question. How many insects would be present after 17 days? So this is a population question, so you're going back to the original. T is in days, so in this case, T is 17. 300 is what we're starting with. E to the 0.01, 17 days, how many insects would we have? You're just plugging it in. 300 E to the 0.01 times 17 days. There would be approximately 356 insects. And again, because we're talking about whole bugs, I went ahead and rounded it up to the nearest whole number. On the test, there is one problem where you will be reading a graph. The graph has two curves. One is the original function and one is the derivative. So it's just important to know that when the question talks about the rate or how something is, how quickly it's going up or how quickly it's going down, that's when you would do the derivative. Okay, so derivative is all about the rate. If they're talking about the population or the original problem, you will look at the original graph. If you understood all of these questions, you are good to go for the exam. If you are going for the notebook check, these are the questions that I will be looking for. If you have every single question answered, you will get 5% added to your exam. I hope this helped you guys feel a little bit more prepared for the test, and I'll see you tomorrow.